except the trajectory, which is still quite strange because it lies within 5 degrees of the plane of the planets around the sun.
It begins without headlines or alarms. An object is already inside the solar system, moving faster than expected, tracked quietly by observatories that rarely speak until they have to. Night after night, its position tightens on the charts. Its path sharpens, and the silence around it grows heavier. Comet Wierzchoś isn't new to the sky, but something about its updated trajectory changes the tone inside control rooms. Fresh calculations pull its path closer to the sun than first believed. The date locks in, January 20th, 2026. Not far off, not theoretical, real. What unsettles researchers isn't just where it's going. It's how late it announced itself. This is a long-period comet, one that should have given centuries of warning. Instead, it appeared already deep inside the system, as if slipping past the outer centuries unnoticed. Models trace its origin back to the deep Oort cloud, a distant graveyard of ancient debris. Objects from there are rare. Worse, they're unpredictable. Many have never felt sunlight before. Their surfaces are fragile, their interiors volatile. When they heat up, they don't behave politely. Inside monitoring networks, brightness estimates begin to change, quietly, upward. Not by a little, by enough to matter. That means activity may not rise slowly, it may jump. Comets like this don't always build a show over weeks. Some erupt in days, some split without warning, some flare, then vanish. And Wierzchoś is approaching the zone where comets stop following models and start following physics no one fully controls. The window is tight, the timeline compressed. There will be little time to react if something changes. Astronomers now ask the question they never like asking this early. What happens when an untouched Oort cloud body hits full solar stress, and what if it doesn't stay intact when it does? And just as that question settles in, new tracking data begins to arrive. Data that suggests the approach phase may already be over, and something else is about to begin. January 2026 is not just a point on a calendar. For Comet Wierzchoś, it is a trial by fire. As the comet plunges deeper toward the sun, it enters a region no instrument can fully simulate and no model can completely predict. Solar radiation begins to strike its surface with brutal intensity, flooding it with heat after billions of years locked in deep cold. Material that has never felt warmth, never moved, never cracked, now faces sudden, violent change. This is not gentle melting, this is shock. Scientists warn that the comet's ice layers may not warm evenly. Instead, pressure can build beneath the surface, trapped gases forcing their way out with explosive speed. When that happens, the comet does not slowly brighten. It erupts. Jets can tear through the crust. Entire sections can break free. The surface can fail without warning. This phase is where comets reveal their most dangerous traits. Astronomers are already watching for signs of non-gravitational acceleration. Tiny changes in speed or direction caused not by gravity, but by uneven outgassing. If Wierzchoś begins venting gas asymmetrically, its path could shift subtly, then suddenly. These deviations may look small at first, but history shows they can cascade fast, turning prediction into guesswork, and prediction matters now more than ever. Even a minor structural failure could cause Wierzchoś's brightness to change dramatically in just days, not weeks, days. A rapid increase could push it far beyond current visibility expectations. A sudden collapse could make it fade or fragment before scientists can react. Both outcomes carry consequences. What makes this moment especially tense is the geometry. Wierzchoś is approaching perihelion at a time when it remains observable from both Earth-based telescopes and solar-focused instruments. This rare dual observation window means scientists are watching the same object from two radically different angles at once. Historically, this exact setup has preceded some of the most confusing and controversial comet events ever recorded. Optical anomalies, unexpected spectral lines, tails that bend, split, or reverse. Some comets have brightened tenfold overnight during this phase, overwhelming models and forcing emergency observation campaigns. Others have simply disappeared, nuclei shattered, debris dispersing so fast that tracking became impossible within days. Wierzchoś is now crossing into that same danger zone. Early data suggests the comet's structure may be less consolidated than hoped. If true, solar heating could penetrate deeper than expected, triggering chain reactions beneath the surface. Each outburst would increase stress. Each release would weaken the core. And with every hour closer to the sun, the margin for stability shrinks. Scientists are not panicking, but they are no longer comfortable. This is the point where comets stop following rules and start writing their own. Models give probabilities, not promises. Instruments capture snapshots, not guarantees. Between observation cycles, something can change, and often does. And the most unsettling part, perihelion is not the peak of danger, it is the ignition point. What Wierzchoś becomes during this solar encounter will determine everything that follows, whether it survives intact, fractures into multiple bodies, or unleashes behavior never documented before. The sun is about to force an answer. Astronomers are watching closely now, because once the pressure breaks, there will be no time to prepare, and what happens next will not reveal itself until Wierzchoś emerges on the other side of the sun, changed, unstable, and no longer the object humanity first detected. That is when the real story begins. By early 2026, observatories across the world are no longer watching casually. They are preparing for sustained, near-continuous tracking, locking telescope schedules weeks in advance. This level of coordination is rare, and it signals concern. Scientists expect that if Comet C2024E1, Wierzchoś, becomes more active, it may remain visible long after perihelion, refusing to fade the way models once predicted. That possibility alone is enough to change everything. What worries researchers most is not brightness, but chemistry. Long-period comets from the Oort cloud are time capsules, frozen material untouched since the solar system formed. When they heat up, they can release gases never before measured. This is why spectroscopy has become the top priority. Every wavelength matters. Every spike in a spectral line could signal something unfamiliar. Teams are now watching for abnormal gas ratios, carbon monoxide, where water should dominate, or unexpected nitrogen compounds rising too fast. Even small deviations would trigger immediate alerts. These are the kinds of anomalies that force emergency observation requests and late-night data reviews. No one wants to be the team that missed the first warning. At the same time, brightness has become dangerously unpredictable. Models no longer agree. Some suggest a slow increase, others hint at sudden jumps. Scientists know from history that certain comets don't brighten gradually, they erupt. A rapid surge could transform Wierzchoś overnight, turning it from a quiet research object into a naked-eye spectacle seen by millions. And those transitions don't come with press releases. They happen between observation windows in silence. Then there's the fragmentation risk. If solar stress cracks the nucleus, Wierzchoś may split once or multiple times. Separate nuclei could suddenly appear, each with its own trajectory and activity level. At that point, tracking stops being routine astronomy and becomes a race against time. Which fragment is dominant? Which one is unstable? Which one is doing something no one expected? every answer only seems to open another question, because if early 2026 reveals something new, something off script, the story of Wierzchoś will no longer be about approach or brightness. It will be about what happens next, after the data stops matching expectations. And that question won't be answered until the comet crosses a line scientists are watching very closely. Perihelion is not the ending. It is the moment of truth. When Wierzchoś survives its closest pass to the Sun, scientists will not relax. They will lean forward. This is the phase where comets stop pretending. Whatever held together before is now exposed to maximum heat, pressure, and internal stress. The Sun does not just warm the comet, it interrogates it. Early models suggest that if the nucleus remains intact, it could stay active far longer than expected. Jets of gas may continue firing for months, keeping the comet bright deep into 2026. That would turn Wierzchoś from a short-lived visitor into a prolonged presence, one that refuses to fade when it should. But there is a darker possibility. If the nucleus fractures even slightly, the consequences multiply fast. A cracked interior could vent material unevenly, creating sudden thrust in random directions. That kind of non-gravitational force can bend an orbit without warning. A small push today becomes a major deviation tomorrow. Scientists are already preparing for this scenario. Automated systems are on standby to rerun orbital solutions within hours, not days. Any unexplained shift will trigger immediate alerts across observatories. This is not routine tracking anymore. This is live monitoring. And then there's the debris risk. A damaged Wierzchoś could shed streams of material, dust, ice, fragments, forming a complex trail behind it. That debris doesn't just vanish. It reshapes where the comet goes next and how close it may come to Earth in future returns. One breakup event could rewrite decades of predictions. What makes this phase unsettling is how little margin there is for error. Post-perihelion changes often happen fast, between observation windows, between data uploads, between headlines. A comet can look stable one night and fundamentally altered the next. That is why January is not the finish line. It is the ignition point. The object astronomers tracked on the way in may not be the same object that leaves the inner system. Shape, spin, brightness, even trajectory, everything is subject to change once the Sun is done with it. And as Wierzchoś begins its outbound journey, scientists are watching for one question above all others. Did the Sun merely scar this comet? Or did it transform it into something entirely different? The answer won't arrive all at once. It will emerge signal by signal, night by night. And what comes next begins the moment Wierzchoś turns away from the Sun.